Okay, guys, I posted for you exam 1, quiz 1 with the due date, so plan to take them on time. They are on iCollege. All our quizzes and exams are in iCollege. Correct, guys? So today we'll start with chapter 13. We started last week a little bit out of it, but today we'll start with chapter 13, which is really about the aldehydes and ketones. So as you will see in this chapter, it's aldehydes, anything with the functional group. This is the functional group for aldehyde. This is a carbonyl group, and there is a hydrogen there, and here is R. R can be any groups. The ketones, on the other hand, you have a carbonyl groups connected to R, R1, R2, whatever. So that's a ketone group because connected to two alkyl groups. But the aldehyde, similar to ketones, however, the aldehyde connected to what? To hydrogen. So the hydrogen, that's the difference between ketone and aldehyde. Now, most of the stuff you smell, flowers or fruits or something like this, you will see this as based on what? On aldehydes and ketones. You will see in nature most of the stuff that's smelling, most probably your thinking will come back and think about the aldehydes and ketones because those are the ones are found in nature with a very distinct smell. Correct? So, saying this, let's start with the chapter. Chapter is not very difficult. We'll concentrate ourselves on the physical properties, and then on naming of those aldehydes and ketones. That's number 2, and then chemical reactions. Okay, so three objects all the time. First of all, we have to know about those type of functional groups, how to name them, what their physical properties, and what their chemical reactions are. So here's just a typical aldehyde and ketone found in nature. And as I said, this is cinnamon here. You have used cinnamon in your food. So this is formaldehyde. We talked about aldehyde being used with the mixture of alcohol to make formalin solution. That's really used as preserving solution, and that's in your biology lab. You get a lot of dead bodies like frogs, cats, kept in a solution. That solution that's keeping the bacteria away from eating that dead body inside is formalin, which is made from formaldehyde plus alcohol. So you can see that the aldehyde group, you will have carbonyl groups plus hydrogen. Okay, and the H can be here any R or any. If you have an H, then you have formaldehyde. Here you have a ketones because this carbon here is connected to another carbon connected to another carbon. So this one here can be visualized like this. So whenever you have this type of setup here, you can see that's a ketone, not an aldehyde. Ketone. So an aldehyde has to have, instead of this carbon, you have to have this hydrogen. Yes?
So what's going to be the difference between header and ketone? Because header is an oxygen to all of it.
Oh, the aldehydes and ketones, the difference between them is their structure itself and their chemical reactions. So their structure itself, the structure of a ketone is a keto group or a carbonyl group. It's a carbonyl group connected to two alkyl groups. That's a ketone group, or a keto group, or a ketone. This is a ketone or a keto group. But if I have the same setup here, and then I say, okay, this is R, replacing R with the H. See, that's the difference here. This H here, that's make an aldehyde. That's making an aldehyde. Okay, guys. So that's the difference between the ketone and the aldehyde. Now, because you have the ketones, you'll see. So the keto group here is a little bit restricted. Restricted by what? By the two R's. And if the two R's are bulky, then the keto group will be inactive. But the aldehydes are more active than ketones. Why? Because you have this small tiny hydrogen there, which is really release the pressure on the restriction on the carbon keto group or carbonyl group. So this one here is more free to react. But this one here with this bulky two R's, if they are very bulky, then the keto group or the carbonyl group here will be restricted from movement, and from even the chemical reaction will be totally different, will be chemical inreactive. So now if you look at those back again, we said this is a cinnamon here, found in nature. This is female estrogen hormone. This is a male. This is male hormone. And this is female hormone. This is estrogen. This is testosterone, which is a male hormone. So you can see both of them is with the ketone group. Why is ketone? Carbon here connected to another carbon, connected to another carbon. It's not connected to hydrogen. And this is the same thing here, guys. This connected to carbon, connected to two carbon. If they connected, the carbonyl group connected to two carbons, that's a keto group now. It's a carbonyl, but the whole thing is a ketone structure, keto group. That's an aldo group. So this is, if this is an aldo group, because this is the distinct feature of the aldo group from the keto group. Okay, so those just an example of the aldehyde and ketones. They're found in nature. I mean, most of the plants, trees, they have those, and they have distinct smell, by the way. So like cinnamon, for example, that's a cinnamon aldehyde, and so on. So as I said, we are concentrating ourselves on the most important naming and physical properties, and then chemical reactions. So this is the characteristics of the aldehyde. As you can see, the aldehydes coming from the carbonyl group. We talked about this. That's a carbonyl group, correct? That's a carbonyl group here. So when it's connected, you connect this one here. That's an aldo group, an aldehyde, an aldo group. This is called here aldo group, functional group. So that's group, correct? That's still an aldo group, but if it's connected to like this, now this one here is a keto group. It's a carbonyl group, but it's now connected to two R's. That's a ketone, called keto group. The carbonyl group in this double keto group, and those are just an example of how the structure of the ketones and the aldehydes are. So, okay, guys. So, and you will see that there. You can later on, you will see in a chemical reaction, you can oxidize further those aldehydes to their corresponding carboxylic acid. Ketones will not do it. Again, we have the same problem with these two R's, preventing this carbonyl group, the keto group, to react very actively to be oxidized. But there is a way to oxidize ketones to carboxylic acid. Okay, so nomenclature. Well, the nomenclature is straightforward. Nomenclature means naming. Nomenclature, the word nomenclature means naming. So we are naming those aldehyde and the ketones. Now the IUPAC naming will be naming for this all is for the aldehydes. Always you put the alkane there, or alkenes, or alkynes. So you try to get rid of the E, of those out. Okay, so the N is still here. The ES out, and then you'll put AL for aldehyde. AL. Okay, guys? So, for example, I have 2 or 3. So here it is, all of it hydrogen, hydrogen, and this one is an aldehyde. So here it is, an example of this. We can say, well, I go by a single bonded, that's alkane, correct? That's what will be propane, correct? So that's a propane. 3 carbons. 3 carbons. So 3 carbons of propane. I take the E out, and then add what? AL. AL at the end. Propanol. Propanol. Everybody's following? Suppose I have a double bond here, a double bond here. That's what will be. Always the priority will be given to the aldehyde. This is numbering 1, by the way, so if we number there, if we have substituent 2 and 3. Always give the aldehyde the first priority, correct? So this will be an aldehyde, because the functional group is C double bond H is an aldehyde, so you count them, that's your aldehyde will take first priority over all hydrocarbons, alkyne, alkenes, alkanes, correct? So 1, 2, 3. So this is what? That's an alkene, correct? Double bond. So this one will be what? Propene, correct? Everybody agrees? Where is the double bond start? Start at 2, correct? 2 propene. Propene. Take the E again. Same thing we did here. Take the E out. Add what? 2 propanol. Are you following me here? So there is a systematic way of the whole thing. Now the problem is when it comes to common name or commercial name, that's a little bit difficult because you have to memorize some of those. But sometimes it's just easy to follow the procedure. If you have a triple bond, that will be alkyne. You name it as an alkyne, and then your number always start with your functional group of aldehyde. Okay? When it comes to ketone, I'll show you how to do that. Similar to that, but we have to watch for the numbering of the ketone. So this is where we can look at the whole thing here. So this is the first one is called methanol from methane, the ethanol from ethane, propanol from propane, and this is butanol from butane. Take the E out, add Al. Now they have a common name. The common name has to end up with the aldehyde. You can see here the common name has to end up with the aldehydes. See here? If I use aldehyde at the end, that means I am working with a common name. So this is the common name of the methanol called formaldehyde. Formaldehyde. So that's what you have to memorize, those common names. There is no system there. But IUPAC uses a system. Use alkane, alkene, alkyne, and then take the E out, and then instead of the E add AL. That's the way it is. So here it is, whenever it's come to common name, at the end you have to end up with aldehyde. Okay, so the methanol, one carbon is methanol, that will be formaldehyde. 2 will be acetaldehyde. 3 will be propione aldehyde. N will be N-butyrialdehyde. So when I say N-butyrialdehyde, this will be oxidized. That's will be butyric acid, which is the butter. We eat butter, correct? And that's the formula of the precursor for making butter here. Butyric aldehyde, that's the common name of it, correct? That's the common name. So let me go further. Here's just the whole thing, what we said. If you have a double bond here, for example, or triple bond, as a matter of fact, you name it as the alkanes first, or alkenes, or alkynes. And then from there, at the number 1 is that's your number 1 here. 2, 3, 4, that's number 4. Where's the numbering of the double bond starts at 3. So it will be 3 butane. This is 3 butane, correct? Same thing. Take the E out, add Al, butanol. And if triple bond will be butane, correct? Butane, take the E out, butanol. And as I said, this is, and then you can count if you have substituents hanging around. So this is number 1. Functional group is number 1. 2, 3, 4. That's what? That's 4. That's butane. That's what? That's your butane. Take the E out, Al, butanol. Where is this methyl group is hanging? Hanging at group carbon 3. So 3 methyl butanol. Correct, guys? Here's very unique. Look at this. This is a very unique name, and this is again, this is number 1, 2, and 3. So 2 and 3, they have what? 2 hydroxy group. If I have an alcohol, the alcohol is less in priority over aldehyde. Are you following me here? So if you so far we can see the priority will come here. Alkanes, write them here. Alkanes, alkenes, and alkynes, and then it goes from there to alcohols, thiols, ethers. It goes here, aldehydes and ketones. That's the priority goes down, meaning increasing. That's the increase in the priority. Who will take the name, the functional group? What we name the structure? So this is the least in the sequence of naming any molecule. This is the highest. Now it goes further. Aldehyde ketones, it goes carboxylic acid, carboxylic acids, and esters. So you can see that the carboxylic acid, they have amino acids, they have but this is what we have to go through naming or function when it comes to functional groups. So you have first alkanes, alkynes. Those the least importance when it comes to naming the structure of a molecule. The alcohols is much more superior than the alkanes, alkynes, alkenes, with the thiols and ethers. Then the aldehyde, It'll take over those. So if I have a alcohol OH group and aldehyde, the structure will be named after aldehyde. If I have an aldehyde group and carboxylic acid group, the carboxylic acid, this alcohol is OH, correct? That's this functional group. Aldehyde and ketones, CHO or CO for the ketones. Carboxylic acid is COOH. So you can see if I have an aldehyde and ketones hanged up to carboxylic acid, the naming will be carboxylic acid will take over. And then the keto group will be named as a keto group, whatever is that might be. Are you following me here? So always this priority, watch this priority is very important, because then you name the compound according to this priority. So if I have an alkanes that have a OH group, alkanes will not name just after alkanes or alkenes or alkynes, will be as alcohol. If I have an alcohol group inside aldehyde or ketones group, this structure will be named as aldehyde or ketones, and the functional group OH will be hydroxy group. If I have an aldehyde and ketones hanged up in the carboxylic acid or esters, then this structure will be named as carboxylic acid or ester, and the aldehyde or ketones will be as a keto group, aldo or keto groups, functional group. Are you following me here? So watch out for this. And this is carboxylic acid, and the ester is just the same thing, OR here. COO instead of the HR. So that's an ester here. That's ester, and this is carboxylic acid. So those they will take the highest priority, and then whatever will come after, hooked up to them will be as substituents, as functional groups. Okay, guys. So I'll go further here and look at the just here nomenclature again. If we have a cyclic, that's a little bit. We name them the same thing, but we have to be just a little bit careful about naming this. So this is an aldehyde. We know this, and this is what? This is cyclic alkanes. Aldehyde will take over the alcohols, ethyl, thiols, and all the hydrocarbons, alkanes, alkenes, alkynes. This is a cyclic one. So the name will be, the aldehyde will take over. The aldehyde will take over. So therefore you have the name of this one here. And this is cyclo from there here. The same thing with the alkanes. We name the alkanes butane, correct? Take the E out, add Al at the end. And here is the same thing. We can say this is cyclo. I can name it here for you. Let me name this one here for you. So how we name this? Just with the same thing we did. So this is cyclo, and what is this? Cyclo what? Pentane, butane, what's hexane, what's that? How many carbons you have in this ring? 5. Here, 5. The first one, yeah, this one. 5. That's cyclobentane. Cyclo what? Bentane. Now, the best thing is to take what we said, according to the rule we have learned? The E out, and then add Al. Bentane-al. Cyclobentane-al. Correct? So that's cyclobentane. Or here there's another name. This is formyl cyclobentane. Well, that will be the correct one according to our rules. According to our rules will be cyclobentane. We name the alkanes, alkenes, alkynes as they are. We take just the E of the alkanes, alkenes, alkynes and add Al to it. That's IUPAC name. And as I said, don't worry about this This common name. Common name is difficult to memorize. You have to memorize many common names. But this one here, the common name and the IUPAC name is the same. This is benzaldehyde. Benzaldehyde. Now, if I want to name it, let's take this one. If I want to name it, differently here, you have to add carbaldehyde to it. That's the common name. But can you think about naming it differently? What do you think if I wanna? So benzaldehyde, that's IUPAC name. But can I a little bit more look at the whole thing? That's not alkane, that's aromatic, correct? That's a benzene. So we can, I mean, according to the theory we started with, benzene, take the E out, add Al. Anytime I have Al, that's an aldehyde. Benzeneal, but that makes it difficult. Correct name, that's correct name, but it's very difficult to pronounce. So the IUPAC said, let's, instead of as benzeneal, benzela, so benzaldehyde. So just take this one here, see, and Al out, add aldehyde to it, benzaldehyde. So now the smell, somebody likes to eat those I don't know what they call it, nuts, different type of nuts. They have very distinct smell and very nice. They taste nice too. They have smell of benzaldehyde. So benzaldehyde, whenever you have a bakery, you start doing some cakes, you'll smell the smell of benzaldehyde. So here it is, and as I said, you can look at the whole thing like this. So now let me take all this out, and if that's for the first one. Now the second one here, that's a carbonyl. The carbonyl is very unique. The carbonyl is very unique naming. When it comes to carbonyl, you have to watch. So the common name is easy for the ketones. So I have one methyl here, one methyl here. I said 2, correct? That's 2, yeah. 2 means di. So I said 2 means di. Di what? Methyl. And this is a ketone group because connected to R and R. Dimethyl ketone. That's a common name. Whenever I end up with the name of the functional group, that's a common name, except with the benzaldehyde. So let me go on. I'll go back to benzaldehyde in a minute. So what's the real name of it? Well, the same thing we did with what? With the alkanes, correct? But now the ending will be different. This is 1, 2, 3. 3 carbons. That's a propane, correct? Take the E out, add O-N-E. So in the aldehyde, we added Al. In the ketones, you'll add, that's for the ketones. You'll add what? O-N-E instead. So this is propanone. Propanone. Here's the same thing. 1, 2, 3, 4. 4, that's a butane. Correct? Take the E out, add O-N-E because here this is R and this is R. Okay, guys? The same thing here. 1, 2, 3, 4, 5, that's pentane. Take the E out because ketone, this is R and this is R. That's a ketone, so add O-N-E at the end. Now, with the ketones, you have to watch the numbering. The aldehyde always number 1. The aldehyde what? Always number 1. The keto group, not always number 1. It can't be number 1. So it can't be number 1. So therefore, let's watch for the naming of this. We'll try to get the ketone number as lowest number as we can. So if I have, for example, if I have something looking like this, carbon, 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 and then here, carbon. Here is a keto group. Carbon, 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 carbon. So looking at this molecule, my intuition will tell me the numbering has to start from here, because here only I have how many carbons before the carbonyl group? 3 carbons. Here how many? 1, 2, 3, 4, 5, 6. 6 ones. Are you following me here? So that my numbering will be here, number 1. So always, that's different. So the aldehyde group, always number 1. But the keto group, always try to minimize its numbering. Don't take the whole long and say 1, 2, 3, 4, 5, 6. That's a 6, that's a number 7. 7 is your keto group 7. No, that's too long. Number 4 will be your keto group. That's a ketone with the keto group number 4. Are you following me here? Always minimize the number of the keto group. So the aldehyde is no problem. The aldehyde is always number 1. That's no problem with it. And the same structure we did. Name the alkanes or alkenes or alkynes, and then just take the E out, and then add O and E. Suppose I have a double bond for the ketones, the same thing. That will be propene, take the E out, propene, whatever the location of the keto group, will be then on, O and E. So we'll see some examples here. So here it is. So you can see the names here. The common names had to add always aldehyde, ketones at the end. Ketones, ketones, ketones. Here, this is a typical commercial name and a common name called acetone. Acetone, correct? It's not acetone, it has 2 carbons. It has 3 carbons. So if we name it, it will be propane, take the E out, add O-N-E. This is R, and this is R. That's a ketone. Add the 1 O-N-E at the end. Take the E out, add the double bond. Here we are minimizing. So 1, 2, 3, 4 will take always to make it. So we cannot be 1, 2, and 3. We cannot do that. Going from numbering from right to left, it's not allowed. It's not correct. We have to minimize the numbering. So I have here will be 3, correct? But if I go this way here, I have it what? Number 2. I have the keto group what? Number 2. So that's the same thing with the examples. We have 7 or versus 4. 4 will win over 4, over 7. So here's the same thing. We have 2 options. Whether we number it number 2, which is correct, or number 3. Number 3 is higher than 2, so 2 will win. Always number the least number. So that's a butane. Where is carbon to the keto group? So it will be butane on, O-N-E. Take the E out, butane. You can name it common name. Just look at this is a methyl, meth, and this is ethyl, eth. So the E will come before, so it will be ethyl methyl ketone. That's a common name. And here's the same thing. I have to number it. So 1, 2, 3, this way, 1, 2, 3. Here the same thing. The carbonyl group is at the 3rd. Whether you go from left to right or right to left. So it will be 3. And how many we have? 1, 2, 3, 4, 5 carbons. That's pentane, correct? Pentane. Take the E out, add O-N-E. Where is your carbon? Carbon 3 is your keto group or carbonyl group. That will be 3-pentanone. 3-pentanone. Or this is ethyl, diethyl ketone. Okay, guys? Going back and looking at the aldehydes here, guys. Just show you here. Those are, as I said, you have to know this IUPAC name because they name them very distinct. So this is benzaldehyde, correct? Now I have hydroxy group. Can I ignore this and say that's a phenol? The answer is no. That's not by all means a phenol. This is not a phenol. So the aldehyde will take first the priority over the phenols or the alcohols. So this is an aldehyde. And this carbon here, number 1, named number 1. So this is number 2. So 2-hydroxy benzaldehyde. Are you following me here? So watch out for this every time for this naming here. So 2-hydroxy benzaldehyde has a name, a common, IUPAC name for that, called salicylic acid, salicylic aldehyde. If you have this one, an acid group here in the top, will be, instead of the aldehyde, carboxylic acid will be salicylic acid. Salicylic acid is used, that's what you will have in the lab to produce what? Aspirin. You'll have salicylic acid and you'll make an ester out of this, correct? That's a carboxylic acid with alcohol, ethanol, and you'll make what? Aspirin out of it inside the lab. Inside the lab. That's one of your experiments inside the lab. You will produce aspirin from the salicylic acid with, instead of the aldehyde group here, you will have carboxylic group there connected instead, and you will react it with the alcohol, and then you'll produce the ester out of that, so which is an aspirin. Okay, guys? So, here's some cyclic ketones. The same thing with the cyclic aldehyde. We have cyclic ketones, and this is the same thing. You name them the same thing. You name what we said, correct? Name them like alkanes, alkynes, alkanes. What's the name of this? That's cyclo. How many carbons we have? 6. That's cyclohexane, correct? That's cyclohexane. So take the E out and add what? O-N-E. Cyclohexanone. Yes?
Is it also a quinone, or is that something else?
No, that's not a quinone. The quinone will be different. The quinone will be, it is, you have 2, that's a quinone. That's a quinone. This looks like a quinone, but let's see here. So here it is. That's a quinone because you have 2 oxygens connected on both sides, top and bottom, 1,4 position. So that's a quinone, but this one is cyclohexanone. So we name it a cyclohexane, take the E out, add O-N-E at the end. So here's the same thing. Now the naming is always, the ketone will be here in the cyclic ring, will be number 1 given, correct? Here's number 1 because that's the first priority, and the whole thing will be named as cyclopentane, correct? Cyclopentane, correct? Take the E out, cyclopentanone. It is cyclopentanone, and the methyl group at number 2. So 2-methyl cyclopentanone. Here's the same thing, guys, we did before with the aldehyde, correct? So how we name it? We name it the same you name the alkanes. This is 1, 2, 3, 4. Minimize the number of carbon of the carbonyl. From left to right is correct, 2. The carbonyl group is number 2. If you go to the from left to right, this will be 3. So the 2 will win. So it has to be this way here, from right to left, when you number this. This is a ketone because this is R and this is R. 2 R groups. So then this is a ketone. So to name this, just add 1, 2, 3, 4, and the double bond there. So this is what? This is a butene, correct? And where is the double bond? At the 3rd, so 3-butane. Take the E out, Take the E out, add O-N-E. Same thing you name alkanes, alkynes. We spend time on naming them, so that's set up for us. Future naming will be easy for us because we know how to name those alkanes, alkynes, alkenes, and aromatics. So then easy to follow the whole thing. So took this one E out, let's add O-N-E. Okay, guys. Now we can look at the some of the names. We said this benzaldehyde, remember? Instead of benzene and take the E out, this is benzaldehyde, correct? This benzaldehyde. Now, if you take the H out, that's benzaldehyde, that's an aldehyde. Take the H out and put any other group here, like this one here, CH3, that's a ketone now, no more aldehyde, because you have two R's here, two R's connected to carbon. That's a ketone group, correct? So this one here will be, the setup here is acetophenone, acetophenone, correct? Acetophenone. So acetophenone, this is by IUPAC name. IUPAC name for this is given as acetophenone. Okay, so this is the whole thing here. That's a ketone here. It's a methylphenyl ketone. If you name it like this, without the common name, it's easier to name here. Is methyl M-phenyl ketone, but the name of it acetophenone. Here you have two of those together. That's benzphenone. Benzphenone. So benzphenone. So if you look at the whole thing here, so this is the structure of the acetophenone. Whatever you bring here will be substituents. That's benz, but you brought another benzene ring, benzphenone. Correct, guys? So, and this one has a unique name. Will be, you have two cyclopropane. So 2-cyclopropane. Correct? So therefore, if you look at this is carbon, will be 1, 2, and 3. So will be here will be dicyclopropyl, because you are like attaching this one here, two of them, cyclopropyl ketone. Okay, guys, dicyclopropyl ketone. So those are naming very strange names, but at least you will have always this alkane. You name them after the alkane. So you name them what? After the alkane. And the problem with the ketone, they cannot be number one. They cannot be number one. Okay, so you have to, in order to have a ketone, you have to have a molecule of 3 carbons. You cannot have ketones with 1 carbon or 2 carbons. You cannot. You have to have a molecule that has 3 carbons. Then yes, that's the starting of the ketones. But the aldehyde, you can have 1 carbon. That's fine. But the ketones start with number 3. 3 carbons. You need 3 carbons to form a ketone. The common aldehydes and ketones, as I said, the formaldehyde. Okay, what we call the formaldehyde, that's a common name. What's the real name of it? We used to discuss it a couple minutes ago, guys. Don't let me down. How many carbon we have? 1. That's a methane. 1 carbon. Carbon equal 1. Take the E out, Al. methanol. Correct? That's a methanol, formaldehyde. You add to it alcohol, and you make formalin solution that kills bacteria, and you use it as preserving chemicals or solutions, so preserving solutions to get the bacteria out of this. Okay, and it's made from oxidation of methanol, correct? Methane, take the E out, it will be methanol. So that's a common name and heavily used, and it's used to make some types of polymer, plastic or something. So it has a lot of usage, and therefore you will see 46 billion pounds per year is made out of it. The second one is, let me see here. The second one is what we call this one here, guys. What's the name of it? That's acetaldehyde. That's a common name. Acetaldehyde, common name. But what the real name? The IUPAC name. How many carbons we have? 2 carbons. That's ethane, correct? 2 carbons means ethane. We don't have a double bond. So this, if you put the structure of it, will be CH, HCOH. Here, H is here all over. So that's an aldehyde, and that's an ethane because it has 2 carbons. Take the E out, add Al. That's ethanol. Ethanol, again, it has can be used by the oxidation of the double bond here, ethenes or ethylene. Now, ethylene or ethenes, ethylene, that's a common name. Again, ethylene is the real name of this IUPAC name is ethene, double bond here. But we call it ethylene because it's going to make a plastic polyethylene. Those plastic bags we keep fruits and meat inside them, those made from ethene polymerization to get polyethylene. Anyway, so this is, can we get this one here differently? Why we have to use only double bond? Come on, guys. If I take an alcohol, primary alcohol, I can oxidize it to aldehyde. So that's not in the slide, but if I have CH3, COH, H, that's a primary alcohol, correct? Not the secondary alcohol. Secondary alcohol, I'll make ketones. So I oxidize this one here. I can get the acetaldehyde, that's a common name, or ethanol. So either I can take the double bond ethene, or I can take the alcohol, ethanol. Alcohol, that's ethanol, means that's what people drink, correct? Coming from fermentation of fruits. You can make it natural from fruits, from whatever. Some fruits, all the fruits will, when you make a fermentation of fruits, you can produce what? Alcohol. And that's the way you can make homemade wine. However, homemade wines or alcohol is not healthy to drink because it has a lot of other mixture of alcohols there inside, including methanol. So you have really to distill the one you have to make inside the home, distill it so it's 78 degrees Celsius. That's the boiling point of ethanol. So you avoid all other chemicals, other alcohols inside with ethanol. So those are 2 simplest one. Now there are many aldehydes can be used. As I said, the smell of the fruits and some of the veggie like cinnamon, cumin, all smell the cumin, cinnamon, all those aldehydes. So they have very distinct smell. So the production of this is a lot to 1 billion compared to 46 billion for formaldehyde. So next we'll see That's now the ketones. You see the ketones here? That's the structure of a ketone. This is the structure of the ketone. Can you see it? That's the ketone. But now if you have condensed and other benzene rings inside it, that's you make alzarin. Alzarin is a dye. So, and that's the good thing about those ketones and aldehydes. Besides their smell, you can make out of those nicer type of organic dyes. Alzarin is nice used to get. You can't see the precipitate inside the organic chemistry reactions. You add to it, and then it will precipitate with a very nice reddish, bright red color. So you can see it's used is really it's like a dye or precipitate. So you can see the precipitate much better. So, but alzarin, yes, it's a very organic dye. And here there's another one here. This one here, this is vitamin K. So this is another one here. This whole thing, vitamin K. You can see this bulky molecule is really the precursor of it is this one here in the middle. Double action. That's a ketone. So ketones are very good organic dyes and precursor for organic dyes. You can dye your clothing, even food coloring material. You can sometimes you have a rice, you want the rice looks yellow or whatever, or the bread, you want to see the bread looking yellow or red, whatever. You use a different type of ketones, will give you different colors. Okay, guys. So those are the ketones here. And if you go higher in chemistry, you'll have the chance to look and work with those coloring dyes. It's very nice. They really you can see they color your reaction, and then you can look at the color they give you, the right colors. So now how this is the chemical reaction of aldehyde. We talked about the aldehyde, correct? And watch out for even the quiz has something, quiz 1 and exam 1, they have something like this. So we start with primary alcohol, correct? We get oxidation here of primary alcohol, that's in the alcohol, correct? You get aldehyde. You get secondary alcohol. You get what, guys? Come on, guys. You know that? Ketones, perfect. Ketones. Now here's the trick. How about tertiary alcohol? No reaction. No reaction because you don't have this hydrogen available there. So oxidation. And watch out for this for the quiz and the exam. Oxidation, no reaction. So we can produce the ketones and the aldehydes from the oxidation of the alcohols. Primary alcohol oxidation will give us aldehyde. Secondary alcohol oxidation will give you ketones. The tertiary alcohol, they will not give us nothing, no reaction. So primary alcohol means you have this OH, whatever this C here, CH2H. The secondary, you have this carbon here is the second one. This is H. This is H. OH is second one. So it has two groups here connected. This one group. The tertiary has R here, R here, R here, and this is OH. So those are the tertiary one.
Question.
Yes.
I'm sorry. But for the primary alcohols, sometimes it says that it can give us the carboxylic acid instead, right?
Carboxylic acid, this one here can go to carboxylic acid.
Is it further oxidation? Or?
Yes, Further oxidation, yes. And ketones, no reaction. However, you can force it throughout some other back, they call it back route, or another route to get to carboxylic acid. Otherwise, it's very hard. You have to have special ketones. Special ketones, this means they have inside them the OH group. So OH group has to be present, the ketones, to get it to carboxylic acid. In the sense, let me write it here. So let me write with other colors. So if I have a ketone, this is a ketone connected to C. The C has OH here, H or C, H3, AH, and then CH3. This type of ketones can be oxidized. But the ketone by itself, the problem is the bulkier those are hanged up to the keto group. The keto group cannot move. So see here are, and if you have all this without the OH, if you have a bulky group here without the OH, take the OH with whatever CH3, another CH3, that's too bulky, and the R is really restricted, cannot really move easily. So that's the reaction is very, very difficult. It's make it easy if you have an OH group here, or an H, OH or H group inside it, so that will be easier for it to oxidize. So that's the reaction here. That's that's the example here. That's the oxidation. So this is an alcohol. And what's this type of reaction? I mean, primary, secondary, or tertiary alcohol here? What do you think?
Primary.
Correct. Connected to the number 1. And all this are. Same thing we did before. That's a primary alcohol. Perfect. And that will give you what? An aldehyde. And then this one here can be further to give you carboxylic acid. This is the functional group of carboxylic acid. Correct. Further oxidation here. Further oxidation will give you the carboxylic acid. Correct, guys? So using an appropriate alcohol, write an equation to show how the following compounds can be oxidized, can be made by oxidation. So this one here, an aldehyde. Correct, guys? How we can oxidize this? From what alcohol we can start? Come on, guys, don't take me down. What's that? The same thing, you start the same way. You start with the same, this one is this, then this, whatever else. It's very bad, so I put it this way here. So this is 5, correct? 1, 2, 3, I'm not good in drawing, so. So bear with me. That's 5. Correct? I'm not touching this, but I'm touching what? I have to have here OH, here H, here H. Correct? If I oxidize, this is a primary or secondary or tertiary? This one here. What is this? Secondary, primary? Which one?
Primary.
Not secondary? No?
Oh, yeah.
Secondary?
Yeah.
Secondary? No? Tertiary? That's a primary one. Come on, guys, give me a break. Give me a break. I just want to see where you are thinking, guys. This is connected to the first carbon. Whatever is connected, I don't care about the rest. It's connected to the first carbon. That's a primary, so this is primary. Anytime that's the OH connected to the first carbon, I don't care about the rest. That's a primary. If it's connected to the second one, if I have a CH here, correct? That's connected to the second one. So this second, this is one, the second, for example. So that will be secondary. If there is another CH3 here, that will be what? Tertiary, because all those three groups. But rather, we don't have a three groups. We have only one carbon. So with the help of oxidation, we'll take we keep the molecule as is, and we change we keep the same thing here as is, no change. Here will be then our OH, H. If you oxidize this primary alcohol, then you get the aldehyde. Are you following me here? How about this one here? What's that? No, we have to find, if we can find this one here. We need what? This one here, this one an aldehyde, but we want to get this one here to this. So show how the following compounds can be made by oxidation. So guys, what I need to get in order to get this one here, if I put this one here, a C here, so this is C already, correct? And I want to oxidize this one to O. What should I do? This is secondary, or if I have to take what? Secondary alcohol, or tertiary, or primary. Here I have to take a primary alcohol. This is primary alcohol. Here, from the theory here, I have to get what? To get the ketones, I have to oxidize it taking what? Secondary alcohol. Correct, guys? So how in the world I will do secondary alcohol out of this one here? Secondary alcohol. So that's challenging. Secondary alcohol to make out of this. So what do you think, guys? This one primary alcohol, this is the OH. So then the OH will be oxidized. You take this one here as with the H catalyst and the H. So H2O plus the aldehyde itself. Correct? Aldehyde is this, the whole thing. But this one here, how we can get it from secondary alcohol? Can I oxidize it direct? What will happen if I take this one here and then let it react with oxygen, pure oxygen? What will happen? No, I'll break the cyclic ring. So will be CO2 plus H2O, whatever the number of carbons you have here, 5. So you can balance the equation. So I'm breaking it if I use. However, if you let it react with H2O, you might be able to get the oxygen, because this is tricky. This is tricky. You cannot get this one here from secondary alcohol, correct, out of this. So how is you get secondary alcohol of this, guys? Come on. I need to get this one here, secondary alcohol. This one here, the OH, correct? The secondary or tertiary alcohol. Come on, guys. Here, see, here we came from this. correct? Can I take this one here and let it react? Cyclohexanol, correct? Cyclohexanol. It has two R's. R here, the rest, and R here. And then I can take that always to this. Cyclohexanol oxidation will lead to the ketone. That's a secondary one. Make sense, guys? Make sense? If you have the OH connected to one R, that's a primary. If you connect it to two R's, that's secondary. So I have to take cyclohexanol. You can review it, and then you can even look at the ebook. So cyclohexanol, I can take this one here, oxidize further. That's secondary alcohol to this ketone here. Okay, so we are doing the reverse reaction. Yes, yes, we are doing the reverse reaction. So now this one here, we have Friedel-Crafts alkylation or acylation. There is Friedel-Crafts alkylation with K, and there are Friedel-Crafts acylation with C, both. So we use aluminum chloride as a catalyst here. So what we are doing here, we are bringing part of this one here. So this is usually the benzene ring does not react. So it has here a hydrogen, for example, correct? This, you can see this benzene ring C6H6. That's a benzene ring. So that's a benzene ring. It has a hydrogen. It's very, very difficult to get it out. But with the help of a catalyst, aluminum chloride, then you can add to it the whole thing, and then the chlorine here will come and react with the H of the benzene. So let me just show you here how the whole thing works. That's your benzene, correct? Carbon H, 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 H. And the double bond is circulating between the whole ring, correct? That's you have six carbons, 6 hydrogens. 6 carbons, 6 hydrogens. Now with the help of aluminum chloride, the CO, just show you here, Cl, and this is another benzene ring. So what's happened is, with the help of this catalyst, only with this catalyst, aluminum chloride, the reaction will not work. If you change the catalyst, the reaction will not work. Very specific to this type of aluminum chloride, they call it alkylation or acylation. So this time here, aluminum chloride will help you to pull out what? The HCl. Then you will add this whole thing together here with, this is one of the, here, the H is out instead of this, the double bond, the whole molecule here will come in. So double bond, okay guys, everybody's following? So we pulled out the hydrogen here, which is almost impossible to pull with the normal conditions. With benzene does not react. Benzene, you can keep it for millions of years, it stays there, it's not reactive because of this double, triple bond moving around, delocalization. However, when you add the catalyst, aluminum chloride, that will help you to pull out whatever this might be, whatever, it can be R, can be bromine, can be iodine, can be whatever, fluorine, can be pulled out, correct, with the H here, one of the H's of benzene ring. As I said, that's impossible whenever you have used different catalysts, will not work. So I'm pulling this HCl with the H of the benzene here ring to make HCl, those two, and then put the whole group here. That's benzo group here inside. So I created a ketone with 2 benzyl ring and the keto group in the middle. This called here, this called what? It has a specific name called benzphenone. It is benzophenone. So this is benz from this, benzene, and this is the aceto group there. So the name will be acetophenone, acetophenone. So acetophenone, that's the name of it. So this is, you tell me what will happen with the second one here. What I'm getting out of this. Come on, guys. What's the reaction? Remember, I'm taking H here out, correct? So I'm expecting my product will be looking like this. The H out, then you have C double bond, CH3 plus HCl. We have a couple minutes, guys. So that's what I got. That's acetophenone. That's a ketone, acetophenone, yeah. So you can, well, or methylphenyl ketone. Methylphenyl ketone, that's a common name. Common name. Acetophenone is IOBC name. Methylphenyl ketone plus HCl. The same thing we did before. The HCl with the H's here together from the benzene, pulling them out, and that's what you are getting there. Okay, guys. So I think the time is. We can do the same thing here. Just if you have a triple bond and you oxidize triple bond, you get a ketone. So the same thing we did with the double bond to get aldehyde. So here it is. That's a ketone. This is R. This is another R. That's a ketone. So we'll come back and look. That's octane, that triple bond you can make out of this octane. So ketone. So we'll come back and then we'll have to have, if you have heptane, heptanone. So this is 2-octanone. Make sure that your keto group has minimum numbering, 1 and 2. You are going this way. You are not going this way. If you go this way, will be your 5, 6 will be your ketone number 7, and that's not allowed. It has to have a minimum number. So I'll stop here, and then we'll come back Thursday to finish up the chapter, and almost there, half of it, I think. I want you to study very hard for the quiz 1, exam 1. It is open book. You can use everything you want except cell phones. Use anything. You can bring literally the whole library in front of you, okay? But you are not allowed to use cell phone. Cell phone means you are depending on somebody else's help. And that's not good for the final exam. Thank you.